Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but a lot of the same principles apply over in the UK as well. Now, if you have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring that. And if you're watching this after the premiere, then just feel free to leave a comment underneath the video, and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on Diagnostics technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had a group of about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, I just became that default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that had come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic at hand today is hybrid and EV diagnosis and repair. There are some similarities between, actually there's a lot of similarities between how they're set up and how they operate. There are some differences, though, so we'll talk about some of the similarities, the differences, a couple techniques to diagnose, and a couple. We'll just walk through a couple of sample vehicles to see what's available. So let's get rolling. First off, we'll start with electric vehicles. So in my mind, an electric vehicle is basically a giant rolling battery, because the largest part of the car, or whatever vehicle it is going to be the battery. Oftentimes on some manufacturers, it's part of the body work, right? So it just kind of goes in there, and that's part of the frame underneath and holds the vehicle together. So we're going to have multiple components that we're going to talk about. First off, being the battery, right? So in the EV world, the batteries are much larger than in the hybrid world. And we'll look at a little comparison here in a minute. On that battery, in order to keep it charging optimally, we either need to cool it if it's getting too hot, or we need to heat it if it's too cold. Saw stories over the winter. People were getting, oh, my range went way down when it was cold outside. Okay, because the battery doesn't run as efficiency there. Now, not every manufacturer has a heating system. Just about every manufacturer would have, well, every manufacturer has some sort of cooling system on there. It just depends on what they use to cool it. Also needs voltage conversion in there. We have multiple different levels of voltage and AC and DC in there, so we need some way to convert all of that. It has a regenerative braking system, so when I hit the brakes, the engine pretty much just like runs in reverse, and then it charges the battery that way. Of course, we have the electric motor. I meant to say motor, not engine, but we have the electric motor, which drives the wheels, and there could be multiple motors on a vehicle. If it's like a four-wheel drive or all-wheel drive, for example, maybe you got one motor in the front that runs both front wheels and two in the back, one on each wheel. And then, of course, a charger, because I'm going to need to charge that big battery that's in there. Always remember, when we're working on any of these high voltage systems, be it a hybrid or a full AV, we need to be worried about safety first. High voltage on these systems. Now, they have generally they'll have a main plug that'll disconnect the battery from everything else. And what some shops have done that I've heard is that they'll do like a lockout tagout thing, like for an electrical panel. They'll lock out that plug, or just have the tech, hey, you got to keep that in your pocket while you're working on it, so nobody just randomly plugs it in, because accidents can happen. So we got to make sure we're really careful around these high voltages. The battery on an EV is multiple small low voltage batteries linked in series, so a couple volts, and then they just run them in series, and that gets us 300, 400 volts or more. And typically nickel metal hydride, or probably now more often than not lithium ion batteries. EVs have large packs and they're quite heavy. They're specialty equipment just to lower them out of the vehicle. They have like a battery table that I've seen in places that's basically like a scissor lift, but with a flat top on the top, and it's like a table, and so you can lower that battery down. Just on, using hydraulics. It's like way over 1,000 pounds. Speaking of heating and cooling, we talked about that a little earlier. Batteries must be cooled to maximize performance in life, and usually they're going to run hotter than cooler. And three methods are used: passive air cooling, which I don't think on an EV they probably use. active air cooling, which would be some sort of a fan system, which I think is also probably rare on an EV. And then liquid cooling, which I think is probably the most common one on EVs. And here we see on a Audi, all the coolant passages there that run over the battery there. Also need to heat it. Liquid cooling can also warm the battery if needed. So it's a specialized coolant, must contain deionized water, because we don't, if there is some sort of a insulation leak or something like that, we don't want to be able to conduct electricity, and deionized water does not conduct electricity very well. And the coolant is either warmed or chilled, depending on the situation. So we got a heater there, and we got a chiller there, and depending on how these valves open up, that's going to either heat up or cool off. Electric water pump, it's going to run off battery, the big battery usually. And oftentimes they'll have a radiator like an internal combustion engine vehicle just to cool off the coolant. The inverter unit, it's going to convert AC to DC and back again, converts high voltage to 12 volts for a low voltage system, or 12 volts into something else, and moves stuff up, down, and all around, and puts the right voltages where they need to go. It also reverses the step up to charge the battery while braking. So we see this the picture from the last slide. High voltage battery assembly, high voltage joint box that goes into the, I guess it's one of the converters, 360 volts in, and 12 volts over here to the 12 volt battery. Got the ECU assembly, which would be the power control unit. Voltage control unit here. Battery management system is going to report available battery power and state of charge. And then it's just going to do what it needs to do and switch things back and forth. Brake switch, shift lever, so it knows what gear it's in, knows whether or not you're braking or anything like that. So it needs to process all that stuff. Now the regenerative braking system transfers energy from braking to charge the battery. Uses the electric motor to brake. And in that case, the motor becomes a generator. So even some vehicles, when you lift off the accelerator, it'll start turning and becoming a generator as like an engine brake. Some manufacturers, it's a little smoother than others, I must say, on the ones that I've driven. And hydraulic brakes are still used because you still have to be able to stop the car, but it's going to try and take that energy as you're slowing down. The electric motor is going to be a high AC voltage, can be 500 volts or more. Used to drive the wheels, of course, used to charge the battery during regen braking, and most are a three-phase AC motor. Now, if you look at this, it's going to depend on what the manufacturer has for existing vehicles that it's putting this electric motor in. Now, for example, if it's a vehicle or a chassis that already has existing internal combustion engines, be it gasoline or diesel, notice how this has a couple motor mounts, and it almost kind of looks like an internal combustion engine, but it's not. And it's an electric motor, and it's got some converters on top and stuff like that. And then there's where the axles come out. So it's like a whole drivetrain assembly, transaxle assembly. So all of it's kind of together. On vehicles that didn't originally have a internal combustion engine in it, well, the motor can be kind of, whatever the manufacturer needs it to be. For example, a Kona EV, Kia Kona, could have a gasoline engine, could have a hybrid powertrain, or it could be fully electric, all using the same body and chassis, so to say. So yeah, they would have to adapt it to work with the platform that's already there. With the motor, we also need a resolver. The resolver is kind of like a position sensor for the computer, so it knows how fast it's rotating and what direction and all that. So the rotor gets pressed on to the shaft, and then the stator stays, stationary. It has windings. It's an electromagnet, so it spins and it generates electricity through there out to the computer. So here's an example here. So here's the motor itself. That's on a Hyundai Kona. I just talked about that. But it's got the whole traction motor there. It's got a bunch of resolver signals in there. Resolver positive and negative, and the different motor resolvers, four different motor resolvers. And then here's our actual control for the motor. It's got three-phase for the motor control unit, right? So it goes out that way. Also has a reduction gear. I wouldn't really call it a transmission, but because it's pretty much straight up connected to the wheels, but we have this reduction gear in there, which changes motor speed and torque. It reduces rotational speed. And when the rotational speed decreases, the torque increases with that. So that's what helps to give us pretty much the instantaneous torque that you might find in an electric vehicle. Then, of course, we have the charger system as well. High voltage battery, of course, needs to be charged either from a home charger or a charging station can be used. Regenerative braking also provides some charge, but I'm thinking it's not going to give you a lot unless you're going down maybe a steep grade in the mountains or something like that, where I have a lot of downward momentum where I can use that to my advantage. But I think just coming to a stop on a flat in a neighborhood, probably not going to give you all that much back to the battery. And then we see this connector here, right? So different standards in the industry. I've read some articles in the last couple of years where some major automakers like Ford and others have been going to the Tesla standard connector, whatever they call that. I forget what the name of they call it, but whatever Tesla uses, a bunch of other manufacturers are going to that standard because Tesla already has all this infrastructure in, and who wants to worry about adapters and all sorts of other things where they can just go in and not have multiple different standards and just have one charging standard for the automotive industry, at least in North America. Not sure how they're doing it overseas. And then we need some sort of logic in the charging system because we have normal charging, which would be maybe plugged into the wall at home, and it goes through the onboard charger that way and then goes into the system. Or quick charging, in this case, we hook up to a quick charger. It's basically a main line right into the battery. We got a couple relays that close, and then when they do, it's going to just basically send it right into the battery and allow it to charge at its, whatever the maximum speed is available for that charger. Here's just an example of that. So this is the high voltage junction block in this Kona that we're looking at. And we have a couple quick charge relays that would go and then just bring the bus bar right to the battery from there instead of going through all this other stuff that's in there. As far as diagnosis on an EV, due to complex electronics, which, it's rolling multiple computers, diagnosis is usually going to be with a scanner. The manufacturer is going to, when you walk through the steps in this example, connect the scan tool to a data link connector. There you go. Usually with a scanner, high voltages require caution working on many components. Rule of thumb, if you see orange under the hood, you probably want to steer clear unless you know what you're doing. And 12-volt systems can be diagnosed like any other vehicle. So they're still going to have navigation and ADAS and seat, power seats and whatever else on the vehicle that would normally run on 12 volts anyways, would also still run on 12 volts, and it would be diagnosed the same way it would on any other vehicle pretty much. Most of them even have 12-volt batteries on board to power those. Same thing with component testing. So if you think about lab scope, guided component testing, that sort of thing, 12-volt systems can be, same applies as what we said before. Most high voltage systems are not suitable to test with an automotive scope. Ours spec says 400 volts DC max, but we say don't hook it up to anything over like 50 volts. So when you're dealing with hundreds, if not, it could be potentially up to 1,000 volts, you need a specialty meter for that. So we have specialty meters that exist for that. I forget what category it is, but whatever that voltage needed, there's specialty, DVOMs for that. Also, there's lots of other specialty tools, insulated screwdrivers and ratchets and wrenches and stuff like that we have. So lots of stuff available if you're going to work on this stuff. You just need to make sure you're smart about it. And don't go near the orange stuff if you're not protected or trained on how to do it. Which, by the way, thought pops in my mind. What sort of training and requirements and licensure do you need in the United States to work on an EV or a hybrid? None. You don't need any. You can just say, hey, I work on EVs and hybrids now and go to town. Now, I would strongly suggest getting more training than this. This is just kind of an overview. I would strongly suggest getting specialized training on working on EVs. So there's plenty of it out there. I know over in Europe, there's licensure and all sorts of things for it over there. So you got to take hours and hours of training to even touch these things. So not sure about Canada. I would imagine Canada's a little more strict too, because they have like their whole apprenticeship program and all that. So let's get to hybrids. What's a hybrid? Hybrid is like a standard internal combustion engine vehicle, but adds on the battery and electric vehicle stuff that is with it. Now, in this case, this looks like it might be a all-wheel drive. Maybe it's a Highlander, Toyota. So it's got a front engine, transaxle, that whole assembly, and then we got the itty bitty battery, comparatively speaking. And then we also looks like there's another motor back there. So this is probably an all-wheel drive vehicle. So they would have multiple drive units. Now, different powertrain types you're going to see is starting with parallel. That's probably one of the more common designs. Getting less and less so over time, I think. But gas and electric motors are linked to a common transmission or gear set, I guess. The generator and the motor are generally grouped in the transmission assembly. So you can see here's the motor there. There's the gear set, and there's the generator there, all kind of in one package that bolts onto the internal combustion engine. There's also a series, you might find out there, and these are very rare. Electric motor drives the vehicle only, and then the gas engine that's equipped is only used to charge the high voltage battery. So this is a little 2-cylinder engine. I'm pretty sure the only one they really show up on, maybe there's a couple different ones, but on the Volkswagen I series with the extended range, those will run a series engine in order to charge the battery to give you more range on the battery. And then we have the plug-in hybrid, which is probably more common nowadays. They're becoming more common. Gas and electric motors linked to a common transmission. Generator and motor are generally grouped in the transmission assembly, just as before. But it has a much larger battery with a much greater range, and the internal combustion engine is used only under high load conditions. So the story goes, if you have like one of those plug-in town and countries or whatever, and you're only going around town every day, 20 miles or less a day or whatever, you might never, that gasoline or diesel engine, whatever might be in it, the internal combustion engine may never turn on because it's there to help turn on the juice up the battery. Or if I have high load. So if I'm driving around just flat lands and going to get groceries and dropping the kids off to school or whatever, I might never get out of electric mode because the battery is just so big that it's able to contain all that. So components are going to be very much the same as the electric vehicle, except for the internal combustion engine, which is an addition. And then the battery, as we said, would be a little bit different, but everything else that's on this list, same list that we had on the EV. The battery is the same principle, just smaller. Multiple small low voltage batteries linked in series, which results in a high DC voltage, 300 to 400 volts plus. Nickel metal hydride or lithium ion, depending on the manufacturer. And it's often smaller than an EV. And to illustrate this, I found this nice little chart from Car and Driver magazine that talks about the different battery packs on Fords. So we got the F-150, which is a hybrid, not the electric one, the hybrid one. A Ford Escape, which is a plug-in hybrid vehicle. And then a Mustang Mach-E, which is a fully electric vehicle. So you can see the different power ratings and everything. 1.5 kilowatt hours for the little guy, up to 99 kilowatt hours for the full electric. And then if we see 77 pounds up to 1,323 pounds, that's half a ton just in battery. So that's a lot of weight. Let's see, pack volume. So 1.2 cubic feet. This one takes up all the way to 16 cubic feet. That's 8 feet by 2 feet or 4 feet by 4 feet. If we wanted to make a perfect square, roughly, right? That's pretty big. And then voltages from 274 to 343. Like I said, they still run in that roughly 300 volt range, and then it gives you the number of cells and energy capacity per cell, etc. So 7.5 kilowatt hours per 100 pounds energy density on the big battery, down to 1.9 on the little battery. So you can kind of see the difference in size that we might run into out there. Generator. In this case, it's in between the gear set and the engine. And it's used by the engine to charge the battery, used to start the engine as well. So it'll run in reverse, and that's your starter. And that's why, we're going to talk about in a little bit, if your hybrid vehicle, the hybrid battery pack goes low, too low, you might not be able to start the car. I know I had, if you guys... guy I used to work with, his son had a Ford Escape hybrid, and the battery got too low and they couldn't start it. And then it also wouldn't take a charge. So there was like some specialty charging that needed to go on with that. And I'm going to talk through that here in a minute when we go live on the tool, show you a couple things that we have in the tool to help out with that. Then we have the converter inverter. Notice how, like I said before, it's 3-phase AC. So for the electric motor itself and the electric generator going back and forth. AC compressors, 200 volts DC in this case. Hybrid vehicle computer, high voltage battery pack, 200 volts there, 200 volts there, 12 volt auxiliary battery. So fuses, cables, relays, high voltage computer. Regenerative braking system. It's going to transfer energy from braking to charge the battery, just like it would have on an electric car. Uses the electric motor to brake. The motor runs in reverse, and hydraulic brakes are still used. High DC voltage on the electric motor could be 400 volts plus, used to drive the wheels, used to charge the battery during regenerative braking, and most are a brushless type of DC motor. Could be AC, depends on the manufacturer. It could run DC or AC three-phase. Let's talk power flow. So there's a couple different phases, multiple different phases that we could drive a hybrid vehicle in. So we have fully electric mode, which is the battery powering the motor, which powers the wheels. Hybrid mode, which the electric motor and the engine both power the wheels. And then engine-only mode, where just the engine powers the wheels and nothing happens back here. Charging mode is going to drive the wheels with the engine and also charge the battery. Or we can run it through the engine charging, and then regen on the wheels. And then we could also have the engine charging the battery with the electric motor driving the wheels. As far as charging here, we could have some engine braking going on. So it charges up there and it actually uses the engine to brake. Charging just through regen. Idle mode, where nothing's going on, vehicle's not moving. And then engine braking, we kind of saw that before. And then charging right through the electric motor. I think some of these pictures might be duplicates, but I just pulled them out of the owner's manuals. All right, let's go live on the tool. Talk about some stuff. I have 4 vehicles to show you. The first one's going to be the longest. And this will be a Toyota Highlander hybrid. And this one's going to be all-wheel drive or 4-wheel drive. Now on our tools, if it's a hybrid, you're still going to see the normal stuff up here, engine, airbag, brakes, etc. But for hybrids and electric vehicles, we also have a subcategory down here of hybrid electric vehicle systems. So we got the hybrid control module, motor generator, rear motor generator. Like I said, it's got a front motor and a rear motor, and power source. So if I go into hybrid control, you see we got codes and data. We got actuator tests. That's going to be your bidirectional controls, turn things on and off. Bunch of different relays, radiator fans, cooling distribution valve, a bunch of different solenoids, radiator fan, coolant pump, negative relay, hybrid battery cooling fan, inverter water pump. So just a lot of the on and offs. Customization, body control with torque demands, we'll customize in there. And special functions, you're going to see like all readiness, ACT position learning, check mode, inspection mode, battery status information update. So what this needs to do is when replacing the hybrid EV battery stack, it's necessary to update battery status info stored in the ECU and turn the lamp off on the meter after the EV battery stack replacement. Use this function to update battery status info temporarily since it takes too much time to update the information automatically by plug-in charging. Basically, it forces the status update. Make sure no codes are stored. Going to go in, it's going to force it. And then it's, in this case, it's going to say no communication because I'm not hooked up to a car. But that would be important to do. And then also we have cruising mode reset in there. And then if we come in here, where is it? There it is. Motor generator. Go to motor generator. Actuator test on that. We got the cooling fan. Routine tests. We got to control the motor and general cooling oil pump. And then for system tests, we have our resolver learning. We talked about that earlier. If you have to do any work on there, you may have to go in and relearn the resolver. There's a learning and an initialization. This function is used to learn and initialize the correction amount for resolver variations. To execute relearning for the resolver when parts are replaced, refer to repair manual when to use this function. It's going to tell you how to do it. And then you can do either initialization or learning. I can't do either because I'm in a simulator. It still gives me an error, even then. Let's see what else. And then also on this vehicle, we have guided component tests. On some manufacturers, depending on what they are and what information we have, you may find a hybrid electronics category in there under guided component test if you have a tool with guided component test. Things like the cooling system pump. It's going to give us information on it. It's going to give us the pinouts and all that, where it is. Do a DC voltage test. It's going to look for voltage. Signature test. It is a pulse width modulated signal, so you're going to see a duty cycle there. And then we have like high voltage warnings, a lot of warnings in here too. So inspection mode, safety gloves, auxiliary battery, service plug. Going to talk all about that. References and such. Okay, so that's the Highlander. Actually, wait a second. I think there was one other thing. Where is it? I think I missed it somewhere. There we go. Hybrid battery charge. So that was under hybrid control under routine tests. Hybrid battery charge. So if you go in there, this is for when the hybrid battery goes low. There's a special charger that you need to hook it up to. And then you would just hit start and then watch your data. What's going on? So active tests cannot equalize the voltage difference of battery cells, but the battery charge current value changes following conditions. So it'll change as it goes. So that's just to help you out. Initialize the battery. If it's too low, you use a specialty charger that's listed there, and then it allows it to fill. All right, that's that one. Then we have a Kia Niro, which is another hybrid. And on this one, Danger, high voltage. So you still see we still have an engine, so that means it's hybrid. Come down here, we got battery management system and some functional tests in here, a bunch of fans and relays. And system tests, going to be inspection of state of charge calibration, isolation breakdown detection functions. So the isolation of the cabling and wiring in there, making sure it's not broken down. Inspection of insulation resistance of high voltage parts. And then if we go into data, anytime you're in a battery management system, you should be able to get data out of it. And more often than not, it's going to be, okay, what are the cell voltages? Now, of course, this is in a simulator, so it's going to be bouncing all over the place. And there's 64 cells in this particular battery. Up top, they're also going to give us what is the maximum cell voltage out of all of them, what's the minimum cell voltage out of all of them, and which cell has that high and low voltage in there. So that's helpful to know, if I was going to disassemble the battery pack, because there are places out there that do it, they'll rebuild battery packs. They would probably want to know which one's which, and also what the variance is. Because if it's in a couple tenths, it's okay. If it goes outside of like, I think more than 3/10 per cell, then you got a problem somewhere. So then you just need to find it. Might be able to break it apart. Like I said, plenty of shops do. And they have a nifty little business rebuilding batteries or diagnosing batteries, stuff like that. So can be done. Next one is Hyundai Kona. Hyundai's and Kia's pretty close, but there is a special test on Hyundai and some Kias that we have in here that I want to show you. So this is, in this case, this one's full EV. And if I go down here and I go into the battery management system once again, and we go to system tests, there is a high voltage battery health check. So this is an automated health check that you can do. And we'll check the health of the high voltage battery. So do I wish to continue? Sure. So it's going to give me state of charge and state of health on the battery. So it should be 100% or pretty darn close with that. Since these both say 0, I hit continue, I'm going to fail. Right? If it was above where it needed to be, we'd pass. And then also it'll do those, pull those voltage PIDs we were talking about a little while ago. Give your max cell voltage, min cell voltage, and what cell has that min and max cell. And then it goes through and we're done. So that's something you could even print that out, right? It's because it's numbers, and we could print that out and show it to a customer if we wanted to. All right, and then lastly, we have our Tesla. So Teslas are a little bit different. Actually, they're a lot of bit different compared to your traditional automotive manufacturers because they never had a internal combustion engine in there, so they never had to abide by OBD or anything like that. So they do it totally different. The codes are different layout on codes, different layout on diagnostics with it. You have to enter a service mode in order to hook up to it, open up the gateway as well in order to work on it. But if you come down here to hybrid and electric vehicles, look at all those modules because it is a purely electric vehicle. So we have like the supercharger, secondary charger, thermal control, charger itself, charge port, battery management system, So if we go into battery management system, you can see there's certain little different codes that need to be reset. Do a soft reset or a hard reset of the module itself. Oftentimes, that is how you fix a problem, or at least that's how you go through and try to diagnose the problem. It'll say do a soft reset. It's basically like unplugging it, plugging it back in type of thing. So oftentimes it's just a reset and that fixes the problem. So kind of interesting the way they do things. Codes are set up totally different. I have a whole class on this I did last year. So if you're interested in learning more about that. Also, to complement these scanner functions, we also have guided component test functions on Tesla. If you go into ABS, you can see all the different ABS module. You can go in there and see the different pinouts and stuff and where it is. Do a DC voltage test, tells you where to plug in, tells you what you should see for power. And the different pins. Brake booster, parking brake actuator, parking brake module, wheel speed sensors. So you can see what the wheel speed sensor looks like. It's an active wheel speed sensor. It's not recommended to measure resistance and voltage using a tester. Doing so may damage the wheel speed sensor. So it's just going to kind of walk you through how to do it. All right. So that is hybrid and electric vehicles. And with that, that's our time here today. So make sure you tune in for new diagnostic content every week. We'll be premiering a new video every Wednesday at 7 p.m. UK time, so make sure to check it out here on our YouTube channel. Please make sure you also subscribe, thumbs up, and ring that little notification bell so you'll know anytime we post new content. With that, time for questions. Now, if you have any questions, once again, if you're watching this on the premiere, just leave it in the live chat and we'll do our best to answer those. Otherwise, leave a comment under the video and we'll get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've been giving you today. Hopefully we'll see you next week, and we'll see you on any of our other videos. Have a good week, have a good night, and take care.